Yeah, thank you for being here. I'm Yosu Kim. I'm a senior applied scientist at Explain. I'm responsible for building agentification framework and SDK. And today I'm going to talk about introduction to agents. So some of you already know what the agents are, and some of you have not heard about that, but that doesn't matter. I will walk through all the basic concepts and techniques with non-technical terminologies so that you can onboard on this bootcamp easily. All right. So why do we talk about agents? Not only in this bootcamp, but everywhere in the news, it says agents are the future. So agents are the future of AI companies promise, and agents are just not just an assistant and it's the future of automation. So there are many news going on so far. So we want to know what the potential is, and more progressive opinions are like this. So could AI create a one-person unicorn? It's a unicorn like a billionaire startup by just one person, because AI agents can replace many labor work done by human. So yeah, I want to be a billionaire as well. So we want to know what is an agent. That's the purpose of this talk. And this talk is divided into three sections. So in we'll divide it in technology, but let's say we only have one agent, then it's a single agent system. We have multiple agents, then multi-agent system, and a little bit of um, advanced workflows. So I mean, these terminologies seem quite difficult, but the actual contents are not really like that. So I'm going to start with this first session. So why do we talk about agents and why we want to use agents? So I will go back to the history of artificial intelligence. So traditionally, AI has been solving very simple and well-defined problems. It's called atomic tasks. So for example, in computer vision, there's a task called object detection. So given an image, you want to know what this object is. So here, the stop sign is seen, and we want to draw a bounding box to capture this object and recognize what this object is. So very simple primitive task. In the language processing, translation would be an example. Given text in one language, we want to translate into another language. But these atomic tasks were kind of solved for a while ago. So we have very decent models for those primitive tasks. And we want to solve more complex and demanding tasks. For that, training models in a pipeline would be a go-to solution. So this is an example of English-French video dubbing. So video dubbing is not really an atomic task because we want to take the video and extract the audio from the video, and we want to detect the voice signals like speeches. Then we transcribe that speech and translate it, and we want to synthesize the speech in another language. So we have a sequence of different tasks. Each of these steps is solved by a very good AI model for atomic task, but we need to design this pipeline carefully to make this task done. Well, this is a nice concept to solve complex tasks, but in real projects, we face many unexpected and non-deterministic issues. So, for example, what if the input video file is in an unsupported or unknown format? And we need to download a new video codec, for example, and apply in this first processing step. When we want to detect the voice activity, if it's mixed with the background music, then how should we split that? What if the speech includes code switching or even not a human language? Or I want to output speech to match the style of the previously processed videos. Usually in a big project, we run this pipeline, this kind of pipeline for hours of videos. These issues cannot be solved by fixed static pipeline. So how can you solve this? Of course, we can solve it by designing a pipeline with many branches. So if the video file format is MOV, go here, or AVI, then go here. We have many different options on the way, and we draw the branch for each and draw a large graph at the end. So this kind of graph is very difficult to design. And if there is an error in the middle, then it's really hard to recover. Instead, we are interested in agents. So agent, as you see in the diagram, it's much simpler than a large complex pipeline. No need to wire the functions, these paths manually, because agent can handle that dynamically. And inherently, it keeps watching the intermediate outputs and try to correct them if there are issues. An agent's behavior is depending on input, history, and exploration. So this is another motivation for using agents. So if you have different kinds of input, then, well, for example, the video file you provided doesn't have an audio track. Then how about providing more subtitle file? Or you look back the history of the executions, then you've been processing news videos, then you want to match the style and tone of the video dubbing. And exploration. So if there are unexpected issues on the way, then the agent tries to come up with a new solution and try to find a way. So this flexibility and adaptability is the key for using agents. Okay, so we now know that the agents are good and more advanced than primitive models or pipelines. We want to explore the components of an agent, how an agent is configured. So there are multiple components, and the first one and the easiest one to understand is a tool. So tools. A tool is, as the name says, a helper who does a specific task, whatever task you want to solve. But it should be clearly defined and small enough. So for translation or speech transcription or object detection, you can find good AI model for each. You can also find them in our platform. And an API endpoint. You need to connect to some external database or server to fetch relevant data. For example, weather forecasting data, there's an API. You can call it and get the data for a specific date or city. And calendar, for example, Google or Apple Calendar, there's an API. You can fetch your own schedule or stock market. These are the examples. And the third category would be utility. So file search or web search or encryption or decryption of the data. These are more like house chore tasks for computer processing. So, or text processing or image processing, or those are not related to external server or AI prediction. So we have these three kinds of tools at hand. And a central component of an agent would be orchestrator. So it's also called central LLM or coordinator. It's basically a large language model. This is a workflow or let's say use case from the orchestrator's point of view. So it reads the user input, the first user query. Please translate the speech into French, and there's an attached WAV file. And accordingly, it selects relevant tools for a step So first, given a speech file, we want to transcribe the speech. So take the speech recognizer of the language English. And then speech recognizer returns the results. The text would be hello world. And then we relay the two results, this hello world, to the next step. So the next step would be actually translating this text into French. So to the translator, it gives this text hello world and provide the final output. Here is the French translation like this. So all these kinds of organizing tasks and delivering this to that and those connections between different components is done by Orchestrator, a large language model. Now, this is actually the main reason why agents are now popular these days. The concept is quite old, like decades ago, there was already a concept called agent, but this Orchestrator LLM is very much advanced nowadays, so we can build very smart agents compared to decades ago. Another core part is planning. So think about the problem and decide on the next step to perform. So given this query, we are given, let's say, Orchestrator is given tools like speech recognizer, speech synthesizer, voice emotion detector or translator, or text normalizer. This is just a small example, so we have only 5 tools, but there can be dozens of more tools. So given those tools, well, what should we do? What can we do as the next step? So its thought would be a speech file is provided, so we have to transcribe the speech first. So that's why the orchestrator decided to perform the speech recognition first. So this kind of reasoning step of sub-steps for the task would be called planning. Another important component is memory. So agent is recording what you have done. So store the execution history as self-contained knowledge. There are 2 types of memories. First one is short-term, previous steps within the current session. So current session means the user gives a query and the agent analyzes the query and executes the relevant steps and probably asks some questions to the user, and there's a back and forth conversations, but within the same session, the tasks are quite related. For example, we have a text result from the speech recognizer, and the agent is given the context like previous history of conversation. User gave this initial query, and planning step was done by orchestrator, and it says we should do speech recognition first, and then the speech recognition tool was called. We get the result. All those history were recorded and given as a context to decide on the next step. Okay, given the history, now I have the English translation of the input, and let's translate it. Then it's calling the translator tool. Another type would be long-term memory. That means not only for this session, but previous sessions of the same agent. So previously, let's say this agent is about language processing, and it already translated many speech files, and its history were stored in this database, external database. And given this new query, translate this speech into Spanish speech, then it gives a query signal to the database and retrieve the relevant session from before. So from past history of the executions. And the context is constructed like this, given the relevant session. I've handled a similar request before, translating English speech into French. So back then I started with speech recognition followed by translation, and probably maybe a user feedback, like the feedback was okay. Then you don't need to reason more and just look back to history and so do what you have done before. So then a speech file is given, then let's run the speech recognizer first. Again, so the same as before. So far, I've just briefly highlighted the main components of an agent. This is a diagram. In the center, you see an orchestrator, which analyzes the input output and think about steps and select the tools. Given the information about many tools here. So here, the solid line is the data flow. Actually, the data is flowing, and the dashed line is giving some reference information. So orchestrator is given the information about the tool and the initial query, and decide on the next step and tool, and call the tool. That's called action. After action is done, it's stored in the memory, and this is passed back to the orchestrator as a history to streamline the next decision. I'll give you an example, a very simple example of a single agent system. So as I said, single agent system is just this one agent with some tools. So let's see a weather agent. You are a weather assistant providing accurate and up-to-date forecasts, including current conditions, future weather, blah, blah, blah. So this is the description of the agent, or in other words, system prompt. And we have this LLM component from OpenAI, and there are tools. Actually, we has one tool, Weather API, so that you can retrieve the relevant, accurate weather from external forecasting services. So this is the flow, example flow. What's the weather like in New York right now? It's currently 72 and sunny in New York with a light breeze. That would be the answer from the agent. Okay, the similar query is shown here, but this is too naive. We want to do some, let's say, cooler stuff. So personalized weather agent. Now you get an access to my schedule in the calendar, and also the map routes in the city I live. Then, good morning, how's the weather outside? Then not only fetching the weather from the forecasting service, it considers your schedule. It's quite humid this morning. Since you usually go jogging, make sure to stay hydrated and weather breathable clothes. So give some useful suggestions as well. So that would be the example of a single agent system. So I only explained very basic components, but they are the core parts of the later sections. Okay, at this moment,
And so there's a question going on in the chat.
okay,
So Vail is asking, can I customize your AI agent to serve as an AI agent in a hospital to give a quick report for doctor about the patient and only talk about healthcare? Can we do this kind of customization?
yeah, of course. Once you have access to all the patient data as a digital form, then it's more technical detail, but given those documents, we convert it into some searchable database, and we can make a search tool for that database and put it into the agent, and let the LLM to fetch the relevant information and make up a text based on those information. This is one of the most, let's say, promising and demanding use case for agents. It's called retrieval augmented generation, RAG, which we will discover how to do it in our platform or SDK in detail in later sessions.
Got it. Thank you.
Okay. All right, then move on. We will talk about a multi-agent system. So we have seen that a single agent is composed of central LLM and a few tools. But let's say the problem we're going to solve is very complicated, much more complex than expected. So here's an example. Given a text, a very complex text about in the marketing domain, and let the orchestrator to decide what to do. Then it says, now I have the English transcription of the input in the marketing domain, and let's translate into French, localizing product names, finding appropriate free translations, alternating tones, shorten text, and high quality, all those requirements. Let's say the agent and the initial query from the user ask about all these requirements. Then a single agent gets puzzled what to do. There are too many requirements to fulfill. Then the thought can be very long like this. And usually it tries to break down into simple subtasks. Produce a draft, search for web for information, edit product names, search again, edit again, adjust again, and so on. So from this single text, just because the text is complex and the initial query, you have a lot of requirements, we have too many steps here. If you encounter too many steps for a single agent, then the performance is usually really bad. That's why we have to think of how to scale the complexity of a task. This is, let's say, a related problem. So if we have these 10 different steps we need to solve, then the context, let's say short-term memory of this session would be very long. Step 1, step 2, step 3, step 4, step 5. So if the context gets too long, then the orchestrator is confused what to do next because it has too many information, too much information here, flowing to the planning step. It confuses the reasoning and even more if mixed with different tasks, not only translation, but mixed with different kinds of tasks. And of course, we need to process these long texts, so it can be really expensive. That's a problem of a long context. That's why we want to provide some individuality. So create a separate agent for each complex task. So each agent has its own context, let's say short-term memory, and LLM as a central LLM, and planning strategy for each task, and different set of tools. So all these things combined, each agent is like a task-specific expert. We need to carefully design the agent according to the different scale. But let's say one agent deals with all these 10 different steps would be not really desirable. So that's why we divide them into some groups and assign one agent for each group. So agent A, OpenAI's LLM, we have, let's say, plan step by step, planning strategy step by step, and we have these tools. Agent B uses Google Gemini and branch out strategy for planning and a different set of tools. So agent C uses Claude from Anthropic and React style. I will talk about that later. So alternating between reasoning and acting style, planning strategy, and different set of tools. So for different tasks, you can plug in different LLM, different strategy, and different tools to make specific agents. That's how we divide, let's say, split the tasks into different groups. If we have individual agents, then we can actually execute them in parallel in principle. So from bottom to the top, it's a timeline. So these three agents have started working for different tasks. And in the middle, there can be inter-agent communication. For example, if you are a developer, you already know the concept of message passing or shared memory or event subscription. That's a kind of communication protocol between different programs. And it can be applied same for the parallelly executed agents. So the communication is not done solely by the central LLM, but inter-agent communication can be done. And as an add-on, you can also put overseer agent to manage the start, end of the agent, or authorize the permissions, or synchronize the timestamps, which is usually done in gaming agents. Yeah, that's the main, also another advantage of having multiple agents in our system. So this is a recap of the workflow or diagram or dependencies between different components of a single agent system. So this is an agent, but now you can put agent in this toolbox. So before, if you remember, we have these kind of tools. AI models for atomic tasks, API endpoints, or utilities. Quite constrained responsibility, but now a tool can be an agent, or agent can be a tool. That means a tool can solve very complex tasks. So, but it's autonomous. So if you just let them solve task A, task B, task C, then they can do autonomously with their own tools. It's very intelligent and adaptive, but they're also very not stable. So,
We have a question in the audience. Zohaib
all
is
right.
asking, would MCP come into play here?
MCP, yes. Here, when you communicate with an agent ABC or communication between the agents and between orchestrator and the agents, then if each agent is deployed in the MCP server, then and the communication is defined with the MCP protocol, then it's implemented like that. So it's kind of implementation detail of these arrows, I would say, or these arrows. All right. I lost the chat window, so okay. I got it. All right. Then I will continue. So multiple agents play in the same place, so that's why it's unstable. They have conflicting objectives of agents, so we often see they are misaligned with the actual tasks, or some agents have duplicated objectives, so there can be redundancy, and failure rate is higher than traditional tools. Like calling the weather API is very straightforward. We just call the API and get the result. But if you call an agent A or B or C, there's always randomness or unpredictable behavior within the execution of each agent. Of course, Explain provides robust mechanism to prevent those unpredictable results. But in principle, in theory, this is really the reason for the unstable workflow and also communication challenges. If you run the agents in parallel, they can be delay and someone needs to wait, or um, they require the same information, then they can be race condition between different agents. So complicated system have complicated problems. That's why we introduce some helper agents or specialized agents for making it more stable. How can we reduce misalignment between steps and agents? Steps means step tasks. And I'm given an initial query or from the user, the system reason about the steps and assign agents to those steps. But this alignment between them can be misleading. Here, there's a helper for that. Mentalist, also called planner. You have already seen this planning component from the single agent system. Let's say this is a extended version of that. You design all necessary steps and their dependencies at the beginning of execution. That's the core part. So given the initial query, please translate the speech into French. Then mentalist agent does this thing. So please generate a list of runnable tasks to solve this problem, given problem. You're given the following tools, like this. Then it generates not only the very next step, but a list of all the steps required to finish this query. So first convert speech to text, then translate the text to French, then generate speech of the translated text. You have 3 steps in a row, and reading this plan one by one, you start with the step 1, the speech recognition. So why do we do planning like this? It focuses solely on the long-term planning. So not only for the very next step, but you think about the future steps and make the sequence of steps organized and connected well in terms of the data flow. So this mentalist agent focuses only on this planning, nothing else, like assigning a tool or running an action or analyzing user query. These kind of things are all given to the orchestrator, and it just focus on the planning, designing the subtasks. So if you constrain the task to an LLM, then it often yields a better result. Then better planning means better task agent assignments and reducing missing steps. Here, the reasoning language models in hype these days, like OpenAI's O3 or DeepSeek's R1, play here. So they are very much suitable for this component. And also we can do replanning during execution if some results of the step has some issues. The next component or helper agent is called inspector. So this is related to the error correction ability on the fly for the agent. How can we handle errors or quality issues of an agents? So we have multiple agents, so there are more chances to see errors. That's why inspector is very important, also called validator. It reviews the output of agents. So here's an example. So hello world, this is a transcribed text, but you see there's slightly different, it's slightly different from before. And the inspector says, please check this if this result is correct or not. And the feedback would be there is a redundant comma at the end of the sentence here. It was an exclamation mark. So in the additional step, this is, well, orchestrator or here the mentalist comes up with the next step, additional step to call text normalizer to remove this or this punctuation or replace with a normal punctuation. Now the diagram is also updated. After orchestrator commands an action, then after the action is done, then it's going through the validator or in other words, inspector. It analyzes the output and give the feedback and also action result to the memory, which is gone back to the mentalist or orchestrator. You see the cycle for each subtask or step. So inspector fix issues before proceeding to the next step. It does not overlook glitches in a successful run, and it's also helpful for robustness to variations and failures of the multi-agent system. Okay, another one is called guardrail. How can we handle unexpected outputs from agents? As you see in the question is quite similar to the question before for the inspector. So actually, guardrail is a part of the multiple types of inspectors. in our platform. So guardrail is detecting or removing unwanted content from the outputs. Let's say we have text with a profanity word. Please check if this result contains any profanity words. Then it's detected and redacted like this. And this redacted output is given to the next step, which is translator. So after this guardrail, the profanity word is blocked and the rest of the steps don't work with the profanity word.
We have a question.
Yep.
So the Sai is asking, can we define our own output schema?
Own output schema. Yes, when you design the description of the system prompt of the agent, you usually also write down which types of output you expect. Is it structured output like JSON or other types of dictionary or plain text? If it's a plain text, you want to put the new line for like double new line for every line, or those kind of details can be also specified. Actually, the next component I will gonna explain is related to that like expected output format.
And earlier when Zohib asked about the MCP, Zohib was not fully clear. If you can elaborate on your answer, that would be great.
Okay. So MCP is basically a communication protocol between agents or other related components. And here, for example, if you allow communication between different agents, like agent A or B or C, then the communication is defined with MCP. Then it plays a role like that. And also communication between orchestrator or this main system with the tool agent A or agent B or agent C. If the agent A or B or C is deployed with the MCP server guideline, then it's just using MCP. It's more standardized and easy to use or easy to track. But there can be also other protocols. It's just implementation detail for the communication.
Awesome. Okay. There is one more question about
Mhm.
how does it solve the tools problem mentioned before? I think you were on the other slide for this particular question.
Tools problem.
I think it was you were here, but that's okay. We can
Mm,
circle back to the question unless you know the answer.
okay. Tools problem. So let's say this is a tools problem. So speech recognizer is a tool, and that tool gave an extra punctuation at the end, which is problematic. Then this inspector agent looks at the output and find any peculiar points and gives feedback. Then the feedback is given to the orchestrator or mentalist to replan the steps or insert an additional step to fix the problem. This mechanism of giving feedback and, let's say, follow-up action is the same for guardrail. Only the domain is different, like profanity word or some sensitive information or biased or off-topic text. So I hope that answers the question. Well,
Yeah.
that's why this guardrail is a neighbor of inspector or validator, or this is also can be grouped as one, like inspection step. Censors the output, and censored output would be given back to the replanning or reassigning step from these two central components. All right. Then the final component, which is called responder or output generator or response generator. So after all the steps are done, after a long plan, specifically if it's really long, then the central LLM or the orchestration may lose context because it's too long and the initial query is wide away from the current position. Then let's say, please translate this speech into French and output only the translated text without punctuation marks. Well, there is a specific requirement here. One of the questions was about this. So output format requirements is given in the user query. Then after many steps, finally we get the French translation, Bonjour le monde, but we need to look back the initial requirements about the output. Please, here's the user's initial query. Please translate this speech into French, like a revamp to revamp the initial requirement and generate a clear response that fully complies with all user requirements or instructions. This kind of, let's say, focusing on the output generation or focusing on the output requirement of the initial query that gives the correct output without punctuation marks. So usually this responder is dealing with these kind of output requirements, include this or exclude that, or formatting instructions like specific structure. So responder deals with the final step, so that's why it's here. It's not, let's say, interacting with the mentalist or tools or memory or action. It only looks back the initial requirement and generate the right output for the user. Of course, for the failed runs, I wouldn't say that multi-agent systems, including our platform, is 100% error-free. So sometimes it causes an error. To make it useful for the modification of the agents or updating the system prompt or whatever. For failed runs, responder also gives failure reason clearly citing the problematic step. That's the role of the responder. So now this is the final, let's say, diagram. And here's an example. Now you see multiple agents, scheduling agents, clothing, health, travel, booking. And this is about weekend plan multi-agent system. You are a weekend planning assistant, help users organize their plans, make bookings, prepare for weather and health, and so on. So as you see, this, let's say, description of this agent is really complex. It has to do with multiple extra information sources and also reasoning steps. So we have different agents here, scheduling agents with calendar and messenger, clothing agents or shopping and analyzing the picture of the closet, health agent, smartwatch or pharmacy, booking agent for the travel and hotel, travel agent for rental car or finding the route. This is example run. I'm thinking of doing something fun this weekend. Any suggestion? So the good thing about multi-agent system is that the query can be quite general. You don't need to specify the details. It tries to find all the details or ask about the details if necessary. So based on your calendar and the weather forecast, Saturday looks perfect for a day trip. It gives an weather information and also health information about the elevated stress. So light outdoor activity is ideal. Also, there is a scenic hiking trail 40 minutes away. Then the user says yes, then book the trip and also analyze your closet and what's missing in your closet. Go ahead with the shoes and order the shoes and how long is the trail, and it prepares the map as well. So all jobs are ready for stepping out to the hiking this weekend. Okay, I think it's a good point to stop here and check if there are questions. If there are.
Not at the moment.
Okay, great. Then this section, the last one, is a sneak preview, let's say, about the let's say future workflows that can be coming. They are quite advanced, so can be difficult, but it's also very interesting. So I won't spend much time here. I'll just show you four examples. So this is the final diagram of our framework. So central LLM orchestrator assigns all tasks, but not really ideal for scalability or dependency or connectivity or robustness. So we have already let's say handled such problems with additional components compared to the single agent system. But still, if you have, let's say, not only 3 agents, but you have 10 or more agents, then there can be also problems. So that's why we don't rely on this fixed framework, but something more complex. So each agent, it can be also a multi-agent system. So it's not a single agent system, but in the toolbox, agent A is also multi-agent system, which works with multiple agents. Agent B is also a multi-agent system, which works with other multiple agents, and agent C as well. So it can be like multi-agent system of multi-agent system of multi-agent system. So it can have such a hierarchy. Of course, this is very, let's say, straightforward design. It solves more complex tasks and towards a more general system. But still top down, you go from the top one to the tools, and agent A's tool is a multi-agent system. You go down deeper and so on. So if you go deeper and deeper, then we lose our control. So we have to trust the autonomy of those systems. This is called hierarchical. And multiple agents communicate with each other. That's a distributed system. It's not hierarchical one. So they are, let's say, on the same level, and they sync the execution while waiting for others, or spread the results, or those things. The inter-agent communication is the key. You have already seen those parallel execution example, and this is often used in social simulations in game AI. And reactive workflow. Agent A has, let's say, receiver of different signals, email, temperature, or sensor signals, or voice signals. So it has an interface with the external world. It's actually, let's say, a big component of the old definition of the agents. It solves tasks or update the memory accordingly to the sensor signals, and it requires rules to trigger actions. For example, the temperature is at least some degree, a certain degree, then we do something like that. And it's keep watching the sensor signals, so it operates without user's explicit input. That's the characteristic. Example would be the Alexa or Echo, sorry, Google Nest or something, smart speaker, or a robot with the multiple sensors.
I have a question.
Yeah.
So, in an advanced workflow, what if instructions contradict with one of the tool agents' instruction? How will it work?
So instruction contradicts with other instructions.
Mm-hmm.
Yeah, that's the key. It can be, well, let's say I will give you two ideas. If you look at the workflow, so during the execution, let's say you see two different outputs from the two agents. Or if you assign a task to one agent and you get the results and get the feedback, and maybe ask another agent to do the same task and get the feedback, and that's all recorded in the memory. And Mentalist can replan the task according to that, or Orchestrator decides which result to take. This is, let's say, moderation or fixing mechanism within the execution with our components. But the question is quite timely because I was about to explain that problem. So this is another solution. We want to maybe modify the configuration based on the experience. If one agent and another agent, their instructions are conflicting each other, then there can be some, let's say, warning signal or weird behavior in the agent execution log. Then reading the log, um, in the next execution, you want to change the instruction of the two, or remove or add tools. Those modifications can be done after the execution. So this is called adaptive workflow. So those problematic runs are stored in the memory for dynamic lookup. And let's say if this log has some problem in A and B, then A is modified to AA and agent B is modified to B plus by changing the prompt or changing the tool set or something. Or create a new agent D, something like that. So this framework or workflow is called adaptive system. Well, in our explains framework, there's a component called evolver. So it reads the execution history and tries to modify the agent configuration automatically. So that's exactly the implementing the adaptive workflow. Okay, that's it. The main contents are done. So to summarize it, single agent system workflow is here: orchestrator, tools, and user query, and action and memory. And the planning is also done within the orchestrator. And why do we use such system? It's simple construction of a system for complex tasks and adapts dynamically to diverse scenarios on the fly. The multi-agent system looks like this. It scales to more complex and distributed tasks, and it has better modularization and coordination between different agents. I introduced Mentalist, Inspector, Guardrail, Responder, those specialized components attached to the workflow to make it more robust. Okay, so much for it. So thank you for your attention, and I welcome more questions.
Thank you, Yun. So that was really helpful. Everyone, thank you for the questions whoever asked in the chat. Now is your time to raise your hands. I can give you the mic and we can talk if you have any questions.
Great.
And if you're feeling shy, please feel free to send your questions in a message. No problem at all.
Yes, I'm also looking at the chat window.
Regarding the MCP question, there was one comment from Zohaib. Let me go to that question. Yeah, so Mahmoud, he responded saying that an MCP is just I think Mahmoud was explaining what an MCP might be. Any other questions, comments, concerns, any doubts? If nothing else, how about you guys can tell me like how do you feel about what you learned? Do you have a better understanding of what agents are? Okay. Thank you, Wasim. Thank you, iPhone. Great explanation of agents. It is quite clear the future for business is not without agents. Very well said.
Thank you.
Awesome. Okay. Keep the comments coming, keep the questions coming. Mike is saying, oh, Mike has a question. With the rapid updates to LLM models, how do you design AI agents to keep up with these changes to stay current? Good question.
Yeah, that's a very nice question and a bit researchy. So the LLM can do more things and more complicated things. So if you look at this workflow, in the future, maybe we have to combine like orchestrator with the responder or orchestrator with the planner, because these big LLMs can do more things better. So the workflow should be simplified. But the thing is, the cost of these advanced models is really, really high. So we need to be careful about that. We should keep this, let's say, um, how do I say, fine-grained workflow. Keep this as it is and manage the cost of each component. That can be still helpful.
Hope that answers your question, Mike. I can see you smiling there, so I think that we're good.
Great.
Whale has the next question. Whale says, can we install the AI agent on a operating system and act as independent with specific missions to do?
Hmm.
That's a
I
thinker.
didn't get, yeah, I didn't get exactly what installing on OS. But usually, the agent is installed and running on a, let's say, individual server and deployed, that we can get an access to it um, from external. What's being done within the agent is independent of the other environments.
Okay. And I think Sai has a okay, Sai, if you want to unmute yourself
Yeah.
and ask away.
Okay. So I have a doubt regarding the agents. So let's say if I want to create an agent which if I want to update my calendar based on a mail or from invitation mail, uh, how will these agents work? I mean, so far we have discussed about the agents where I trigger the action or the prompt. Based on my prompt, it will send it will use one of the tool to query some information. But if I want to keep on checking on triggers from external, like for example, emails here, can agent be helpful in this scenario or yeah, that's my question. I don't think I'm clear.
Yeah, it's quite clear to me. So this is exactly this advanced workflow. So what I explained as a single or multi-agent system, it depends on the user query, but there can be consecutive and, let's say, continuous signal from external environment, which can be email message. Let the agent run, and you put a component to periodically check the email and pass it to the orchestrator or the mentalist. You can for sure configure the agents like that, but in that case, you should make sure that it's running all the time.
Okay.
Yeah.
So it should run all the time and keep on checking for the triggers, right?
Yes.
Okay, cool. That was my question. Thank you.
Thank you, Sai. We have another question in the chat. Angie is asking, would it be right to say that when an agent is built, it will be company or industry specific as it becomes fine-tuned on the specific areas?
An agent is built, it will be specific, fine-tune the specific areas.
I think Angie's saying like, will it be very domain specific when we build an agent? Is what my understanding is.
Yes. Yeah, it's your choice. There can be many different points you can customize or put the domain specific taste. Let me give you an example. So here. So this multi-agent system, usually you are writing a description here in the center. This is what you can inject your domain knowledge here, giving background information or backstory here. Or let's say this is very daily life example, but let's say this is, for example, a calendar is actually basically retrieving something from the database. So if that database is very curated, encrypted, specific to a certain company or domain, and then you have an access to export information here. So in that way, like for example, description or prompt, or plugging in external database as a tool, that's a standard way to make it domain specific, make your system domain specific.
Gotcha. Thank you. Diego has a question. Do you think that the complexity of the agent is proportional with the nurturing that the user or creator decides to provide? Or with complex agents, they can nurture themselves?
I don't get
Interesting
the
question.
word nurture 100%. So
I think it's more like in the lines with can they evolve or enhance
Yeah,
the
exactly.
complex?
Can y'all hear me? That's
Yeah.
my question. Okay, perfect. So the thing is, with more complex agents, for example, when you create a chatbot or when you create an assistant, you have to give context, you have to provide information for it to evolve or know the specification that it needs to conclude. The word nurturing, I use it in a context of growing and evolving, as you said. So my question is, when creating an agent, do you think that it's proportional, the amount of information or evolving that I make him do? Or with more complex agents in the future, do you think that they can nurture themselves and learn like independently without my needing?
I see. A clear answer would be, I would say it's more depending on the information you give at this stage of technology. But the future goal of all the agent research is about the latter, what you said in, let's say, evolving by itself, by trying, let's say, trial and error from the same agent, collect experience, and evolve continuously. But this is, let's say, still theoretical, and practically it's not really, let's say, not really working in practice. So at this stage, I would say the information you give about new things and new stuff that would trigger the evolvement of an agent for several steps, maximum. So after that, it keeps continuously growing. That's kind of future research also.
Okay, perfect. Because just to make like a quick point, I've read, I don't know if you guys are deep into prompt engineering, but with meta prompts, I think that when you say that you can put two agents working simultaneously within one context, I think if you manage to find the balance between both of them, I think they could meta prompt one with each other and then like nurture themselves without having to put any input like manually. I think that could be one of the points that can be worked in. But I don't know if that makes sense or if that just like an
Yeah, that's a good example, and it definitely makes sense. It's a promising direction, but still those researchers are working with, let's say, easy examples, which is not really closer to the level of enterprise solutions or complex tasks that we want to solve. But in simple tasks, some tasks is working, like agents evolve themselves. But for practicality, we need a long way to go.
Thank you, Diego. Thank you, Yunsu. We have another question from Ibrahim. What's your approach to data sourcing and how you ensure it's both high quality and ethically gathered?
Mm, this is a very important question, but actually a bit out of scope of this session. So you can make this kind of multi-agent system with good inspectors to actually gather such data. So you can make a data collector agent or data sourcing agent. You can put external database or web search or many validation steps to make it more robust. That's one way to automate the data sourcing. Yeah, that's one way. But other than that, like involving human experts, that should be, let's say, highly domain specific or task specific. So I cannot give more profound comments.
No problem. Okay, so I think, oh, there's one more question. Can you talk to disaster recovery and high availability as it pertains to agents? And self-healing.
And self-healing. Do these terms related to agent research or the problems in the real world? Self-healing
so
or
it's,
disaster?
can you hear me?
Yes.
Yes.
Yeah, it's very common in the cloud world, right? Like, for example, Azure, AWS, etc. They have to think about the virtual machines. If it fails, what happens? So here, like the respondent node, orchestrator, planner, or the tools, I see a lot of scope where things can start failing, and then the whole thing can go completely awry. So that's the self-healing part. So similarly, you can have disaster recovery and the high availability, because that's all going to be very, very critical in mission-critical applications.
No, I see. That's a good point. When a tool is dead or an agent is not accessible or some failure mode is discovered, then usually in the system I described, it tries to call another tool or more general tool to, let's say, give suboptimal solution for the step. But I would say that's not ideal. So from the deployment side, there should be more technical assist when you serve the tools. That would be my answer.
What would be the most common, most complex agentic system that has replaced a traditional, let's say enterprise, workload? or system?
Historically, I have no idea. We are still in the stage of replacing them. A simple example would be just the ChatGPT you are using is already an agent. It reads your text input. If it's related to web search, it calls the web search tool. If it's related to image generation, then it generates a Ghibli image. Or if you turn on the voice mode, then it calls also the speech related tool. So there will be daily life example, but enterprise scale, yeah, we have to still investigate and apply the solutions.
I feel like full replacement of any enterprise system, we are still not there yet, in my opinion. We're still advancing, working on enhancing our agents, and like because we still have the human in the loop, and I feel like it's going to stay there. So yeah.
So one other quick following question on that. So you mentioned ChatGPT. So do you think the next thing would be the reason why they have not released the video at the same time is that just they need to build a similar agentic model for that? Is that right? Or the tool to work with that?
Yeah, definitely. I mean, I cannot say on behalf of them, but the general trend would be adding more modalities, adding more tools, video generation, or if you put it's already there, but if you put PDF files, they call the PDF read tool. If you put table, then they call a table reader tool, and it's expanding. But it's like customer specific, let's say, product for general customers. So the focus would be a bit biased to daily life tasks.
You.